In AutoCAD, object snaps provide a way to specify precise locations on objects. This ability is critical when creating accurate drawings. For example, you can use object snaps to create a line from the center of a circle to the midpoint of another line. In this case, with this drawing zoomed in, you can see the overlapping lines and irregular line lengths. This is an example of a drawing that was not created using object snaps. Without using object snaps, drawings are much more likely to be inaccurate. When the object snap function is turned on, it becomes active as soon as a drawing command does. For example, with a drawing already open that contains objects, from the ribbon, Draw panel, select Line. Hover the cursor over part of the object. Both a marker and tooltip appear. In this instance, it is the endpoint of a line. Note that the marker will change based on its location on the object. For example, a center or midpoint appears differently than an endpoint does on the same line. If you need to use one or more object snaps repeatedly, you can turn on running object snaps. Running object snaps persist through all subsequent commands. For example, you might set endpoint, midpoint, and center as running object snaps. To toggle on running object snap, from the status bar, select Object Snap. Then, on the status bar, click the down arrow next to Object Snap. From this menu, select the object snaps that you want to persist. Notice that check marks appear next to the object snaps that are already enabled. Even while selected, you can suppress running object snaps temporarily by using an override key. For example, if running object snaps are turned on, but you want to turn all of them off for a single point, you can hold down F3. When you release this key, running object snaps are restored. You can also specify a single object snap. A single object snap stays in effect only for the next point you specify. To do so, begin the line command again, then press Shift and right. Click to display the Object Snap shortcut menu. Select Midpoint. Now when you hover your cursor over a line in your drawing, the midpoint is the only active snap. Click to specify the first point of the line. Notice that once the first point is placed, the program suggests the running object snaps again. Specify the second point at the endpoint of a line. Object snaps are a great tool for creating accurate drawings. In AutoCAD, you can select one or more objects. This option is available whenever the program prompts you to select an object. With a drawing open, and with objects already in place, from the ribbon, Home tab, Modify panel, select Erase. Select a single object by clicking on it. As soon as you do, the object highlights. To deselect the option, from your keyboard, hold Shift and click the object again. The object highlight turns off. You can also select objects with a window selection or crossing window. These types of selections make it quick and easy to select multiple objects at once that are close together in a drawing. Choose a location in the drawing area, away from a few objects you want to select. Then, click and drag your cursor toward the right. The rectangular window highlights blue, indicating a window selection. With window selections, only the objects that are completely enclosed in the rectangle are selected. Now, while you are still holding down the mouse button, move the cursor in the opposite direction. This creates a crossing window that highlights in green. Objects that are both enclosed in and crossed by the window are selected. Click to specify an opposite corner to create the crossing window. Once the selection is made, notice that the command line displays the number of selected objects. With the Erase command still active, make another crossing window. This time, practice creating a crossing window that does not include any object fully. The command line updates with the additional selection count, displaying the number of objects from both selections. Again, because these are both crossing windows, the count includes objects that are both enclosed in and crossed by the border of the crossing window. Create a window selection this time. Include objects that are not fully within the window selection boundary. Notice that the additional selection count does not include the objects not fully within the boundary. The program also ignores any objects selected previously. In this example, the command line displays that 2 objects were found and 1 was a duplicate. Thus, the program only adds a single new selection to its count. While you can easily create window selections or crossing windows by moving your cursor in specific directions from the initial point, you can also override this behavior to create a crossing window no matter the direction you move your cursor. Before picking your first point, on your keyboard, press C and then Enter. Now you can move your cursor in any direction to specify the second point and still create a crossing window. To do this with a window selection, you would pick a first point and then press W and then Enter. Knowing the ins and outs of how AutoCAD handles object selection makes it easy to modify several objects at once. A line type in AutoCAD is a visual property assigned to geometric objects. Line types can be a pattern of dashes, dots, text, and symbols, or the current line type setting defines the default appearance of all new geometric objects. With a drawing open, you can review the current line type. On the ribbon, Home tab, Layers panel, select Layer Properties. In the table in the Layer Properties dialog, in the Line Type column, review the assigned line type. The current layer is selected, and the other layers' line types also display. In this example, all the line types are continuous, meaning the line type displays objects with a solid, unbroken pattern. To modify the line type of a layer, click within the Line Type column for the layer. The Select Line Type dialog displays. In this example, several other line types are available. A preview of each line type is visible, as well as its description. To add more line types to your drawing, click Load. From the Load or Reload Line Types dialog, you can choose from the already existing options, or you can load a .lin file. To load your own, click File. Then navigate to the line type file in your file browser. To load one or more line types from the already existing options, select which line types you wish to add. To select multiple line types, make the selections while holding Control on your keyboard. Once you have your selection, click OK. Back in the Select Line Type dialog, select one of the line types that was just loaded into the drawing. The line type for the layer selected in the Properties palette updates accordingly. Line types are a great way to easily differentiate between the various objects in your drawings. A polyline in AutoCAD is a connected sequence of line segments created as a single object. You can create straight line segments, arc segments, or a combination of the two as a single object. Also in AutoCAD, you can define the width for the polyline segments and taper the width across the segment. Varying your line widths in combination with drawing lines and arcs allows for the ability to draw anything. To begin, from the ribbon, Home tab, Draw panel, select Polyline. In the drawing area, pick a starting point. Then, to create a taper, right-click, and from the shortcut menu, select Width. In the field, enter a value of 0. Next, specify the ending width of the segment using a different value, such as 1. Pick an ending point for the polyline segment. Now, move your cursor as if to pick the next point. Notice that this new polyline segment is the same width as the last value you entered. To change this, right-click and then select Width. Enter a different value, like 0.5. Then pick an endpoint for the second polyline segment. Polylines can also include arcs. Right-click and this time from the shortcut menu, select Arc. Pick an endpoint for the arc segment of the polyline. If you make a mistake while creating polylines, you can undo any of the segments you created. Right-click and select Undo. The arc is removed from the drawing. Draw another arc segment. Right-click, select Arc, and then place an arc into the drawing. If you want to have arcs in different directions in your polyline object on your keyboard, press Ctrl, pick another point, and the arc is now drawn in the opposite direction. Undo these newly created arcs and create an arc polyline segment with a width of 0.5 again. Once you are satisfied with your polyline, you can complete the command by pressing Enter. Polylines are an easy-to-use tool to create singular objects of various shapes. In AutoCAD, you can combine one or more objects to create a single object. These compound objects are known as blocks. Commonly used for symbols, parts, detail views, and title blocks. Blocks ensure consistency between identical copies of objects. When creating blocks, it's easiest to work with objects that already exist in a drawing. Open a drawing that has several individual objects already in place, such as arcs and lines. In this example, a desk is made of individual lines and polylines. You can convert this desk into a single block, making it much easier to copy, rotate, and move. To do so, from the Insert ribbon, Block Definition panel, select Create Block. In the Block Definition dialog name field, enter a unique name for the block, such as Large Desk. Then, define a base point. A base point is used for placing the block in a drawing. From the Base Point group, select Pick Point. In the drawing area, specify an insertion base point, such as the corner of the desk. Once you specify the base point, the Block Definition dialog opens again. Notice that in the Base Point group box, the X, Y, and Z coordinates are assigned values. Next, specify the objects included in the block. From the Objects group box, click Select Objects. Then, in the drawing area, use a window selection to select the objects. Note that you can use any selection tool to make this selection. Once the objects are selected, right-click, or from your keyboard, press Enter to confirm the selection. The dialog appears again, this time containing the preview of the block to be created. Back in the Objects group box, you can specify what to do with the original objects you selected. You can retain the objects, which keeps the objects in their original form, convert the objects to a block, or delete the objects from the drawing. Deleting the original objects from the drawing maintains the block of objects, but the individual objects, such as lines and polylines, will be deleted. Select Delete. In the Settings group box of the Block Definition dialog, you can specify the insertion units for the block reference. The Hyperlink option associates a hyperlink with the block definition. Under Behavior, you can specify whether the block is annotative, which automates scaling. This is useful for objects that are symbols, such as labels. You can also specify whether the block scales uniformly and whether you want to be able to explode the block. Not allowing the block to explode will ensure the preservation of the block, as it will not be able to be converted to its original individual parts. Click OK. The individual objects are deleted from the drawing area and are ready to be inserted as a singular, repeatable block. Blocks are an excellent way to streamline and standardize workflows. When editing or redefining block definitions, all reference blocks in the drawing update automatically. Plus, working with block references reduces the file size of the drawing when compared to object geometry duplication. Multiline, or paragraph text, consists of one or more lines of text or paragraphs that fit within a boundary that you specify, essentially a text box. All the lines of text within the boundary are treated as a single object, regardless of the number of individual paragraphs or lines of text it contains. From the ribbon, Home tab, Annotation panel, select Multiline Text. This tool can also be found on the Annotate ribbon, Text panel. First, you create the boundary of the text by specifying the opposite corners of a rectangle. Click to select the first point. You are then prompted to select the opposite corner, but before you do, you can choose other options. For example, you can set the height, justification, line spacing, rotation style, or width of the text, or you can even create multiple columns of text. In most cases, though, it is easier to click the opposite corner to finish creating the text boundary and then set the text options after. As soon as your text box is created, you are ready to start typing. The ribbon changes to the Text Editor Contextual tab, which contains numerous options for adjusting the style, formatting, and paragraph settings. There are also tools for controlling text columns, inserting symbols and fields, checking spelling, and more. The controls in the text editor should look familiar to anyone who has used a word processor. For example, from the Style panel, you can select the style and set the text height. From the Formatting panel, you can make the text bold or italic, create underlined text, and change the text color. From the Paragraph panel, you can change the text justification, create numbered or bulleted lists, adjust line spacing, and more. In the Drawing area, you see the Text Editor. A ruler extends across the top of the editor. On the Text Editor Contextual tab, in the Style panel, text height field, type 1, and then press Enter. This changes the text height to a value of 1 unit. Type the following. This is an AutoCAD multiline text entry. Word wrap is automatically applied as you type. Therefore, don't press Enter unless you want to start a new paragraph. If you don't like where the lines break, drag the right end of the ruler to change the right margin. You can automatically change the text into multiple columns. Click and drag the right edge of the first column. You can then adjust the height of each column individually. You can also make changes to individual letters or words, similar to a word processor. Double-click to select the word Multiline. In the Formatting panel, click Italic. Select AutoCAD and click Bold. With AutoCAD still selected, use the Color drop-down to change the color to red. Also with multi-line text, you can automatically create numbered or bulleted lists. Move the cursor to the end of the sentence and press Enter. Type the number 1, add a period, then a space, and type red. An icon appears, indicating that you just started a numbered list. Click the icon to see options for controlling the numbering. With the cursor at the end of red, press Enter to start a new numbered line. On the second line, type 53 inches. Select the 3, and in the Formatting panel, click Superscript to turn the entry into 5 cubic inches. When you are finished entering your multi-line text, you can close the multi-line text editor. On the ribbon, click Close Text Editor to end the mtext command and close the Text Editor Ribbon Contextual tab. You can also press Escape to exit the multi-line text entry, but you will need to confirm that you want to save any changes. When you hover the cursor over a closed multi-line text entry, the text highlights, and you can see that it is a single mtext object. Click to select it. You can see a blue square grip indicating the insertion point. Click and drag it to move the multi-line text box. There are also blue arrow grips denoting the right and bottom bounding areas of the text. Use these to adjust the size of the text box horizontally or vertically. You can also use these grips to make your text flow into additional columns if needed. In AutoCAD, a hatch object allows you to fill existing objects or enclosed areas with hatch patterns, solid color fills, or gradients. Like most objects, hatch patterns are typically created on the current layer, and they take on the current color, line type, and transparency. However, you can specify the layer on which the hatch objects are created. So, best practice for hatch patterns is to add them on their own layer. That way, you can easily hide hatch patterns by turning off the hatch layer. This drawing includes a layer called Hatch. From the ribbon, Home tab, Layer panel, make sure that the current layer drop-down is set to 0. To add a hatch, from the ribbon, Home tab, Draw panel, click Hatch. When you start the Hatch command, the ribbon changes to the Hatch Creation contextual ribbon. These tools let you select the hatch pattern you want to apply, as well as control its color, background color, transparency, angle, and scale. Expand the Properties panel. Here, you can specify the layer on which the hatch will be created. Expand the Hatch Layer drop-down and select the hatch layer. In the command window, with dynamic input enabled at the cursor, you are prompted to pick an internal point. In the Pattern panel in the ribbon, you can see the hatch pattern that will be applied. When you move the cursor into a closed area, a preview of the hatch appears. Move the cursor outside the area, and the preview disappears. If you click inside that area, the preview is added to the drawing. You can still make changes to the hatch. For example, you can use the Scale field to change the scale factor for the hatch. You can also change the hatch pattern. If you select the wrong area or object to hatch, just use Undo to remove the hatch, and then select a different object or click inside a different area. Keep in mind that this is now a preview of the hatch. In the command window, you can see that the hatch command is still active, and the hatch creation contextual ribbon is still visible. Once you are satisfied with what the hatch will look like, you can either click Close Hatch Creation in the ribbon or just press Enter. Start the hatch command again. Move the cursor over the part of the drawing where there are two intersecting squares. When you move the cursor over the overlapping area, the hatch preview displays just inside that area, even though it is formed by the two separate objects. Click inside that area, and then click Close Hatch Creation in the ribbon to complete the command. Alternatively, you can select an object first and then apply the hatch to it. From the ribbon, Home tab, Draw panel, click Hatch to display the Hatch Creation contextual ribbon. This time in the Boundaries panel, click the Select button. You are prompted to select Objects. Use any object selection method to select the hexagon. Now you can see a preview of the hatch pattern to be applied, which fills the hexagon. AutoCAD ignores the circle and hatches right through it because you did not select the circle. You are still prompted to select Objects. When you select the circle now, the hatch pattern no longer fills the circle. Again, when you are satisfied with the appearance of the hatch, you can press Enter or click Close Hatch Creation. Erase the last hatch of the hexagon by clicking it and pressing Delete. From the ribbon, Home tab, Draw panel, click Hatch. Since the last method you used was to select Objects, that has become the default. In the Boundaries panel, click Pick Points. You are prompted to pick an internal point. Move the cursor into the area inside the hexagon, but outside the circle. AutoCAD now detects the circle inside the hexagon. This is because the Pick Points tool automatically detects closed areas, whereas the Pick Objects tool hatches only the objects you specifically select. Once again, when you are satisfied with the appearance of the hatch, you can either click Close Hatch Creation or simply press Enter. In AutoCAD, dimensioning is the process of adding measurement annotations to a drawing. Dimensions indicate the size of the objects in the drawing, and often include the units of measurement, so it is important that they are both accurate and legible. You can create dimensions for a variety of object types in many orientations. The basic types of dimensions are linear, radial, including radius, diameter, and jogged, angular, ordinate, arc length. Linear dimensions can be horizontal, vertical, aligned, rotated, baseline, or continued. They are sometimes referred to as chained dimensions. You can also create baseline or continued angular dimensions. Although adding dimensions to a drawing can be time-consuming, the dim command helps speed the process because it automatically recognizes objects and defaults for the appropriate dimension type. By hovering the cursor over objects, lines, or points, you can place linear, angular, radial, diameter, baseline, and continued dimensions. You can also use command options to place arc length and ordinate dimensions, add center marks or center lines, adjust dimension text, align dimensions, change the spacing between dimensions, and control the layer on which dimensions are created. From the ribbon, Home tab, Annotation panel, click Dimension. You are prompted to select objects or specify the first extension line origin, and you can see that there are also a number of options. In most situations, you do not need to choose an option. For example, in this drawing, when you hover the cursor over the horizontal line at the top of the object, you see a preview of a linear dimension, and you are prompted to select the line to specify the extension line origin. Click to select the line, and then click to place the dimension. The command remains active so that you can dimension another object. When you move the cursor over the angled line at the bottom right, you see a preview of an angular dimension aligned with that line. Click to select the line, and then click to place the dimension. The command is still active. Hover the cursor over the circle, click to select it, and then click to place a diameter dimension. Now, hover the cursor over the arc in the upper right corner. The arc is identified, and AutoCAD correctly assumes that you want to place a radius dimension. Click to select the arc, and then click to place the dimension. When you are finished creating dimensions, press Enter to end the command. In most situations, the dim command enables you to create multiple dimensions with minimal input. This results in instant groups of appropriately spaced ordinate, parallel, or symmetrical dimensions that appear on the appropriate specified layer. Using the Dimension Style Manager, there are more than 70 settings you can use to control nearly every aspect of the appearance of dimensions. From here, you can also save collections of settings as dimension styles for reuse, or you can save your dimension styles, your drawing templates, so that they are available each time you start a new drawing. In most situations, when you add a dimension, it is created using the current dimension style and placed on the current layer or on a layer that you specify. But when you create a baseline or continued dimension, by default, the new dimension inherits both the layer and dimension style of the dimension that is being continued or used as a baseline. Dimensions have several distinct elements, including the dimension line, extension lines, arrowheads, and the dimension text. Dimension text is a text string that usually indicates the measured value. The text can also include prefixes, suffixes, and tolerances. A dimension line indicates the direction and extent of a dimension. For angular dimensions, the dimension line is an arc. Arrowheads are displayed at each end of the dimension line. You can specify a variety of arrowhead sizes and shapes from those that come with AutoCAD, or you can create your own custom arrowheads. Extension lines, also called projection lines or witness lines, extend from the feature to the dimension line. Typically, when you create a dimension, AutoCAD automatically creates extension lines and leaves a gap between the object and the extension lines. When you use Object Snap to place dimensions, by default, existing extension lines are ignored so that you do not inadvertently snap to an extension line while attempting to pick nearby geometry. To control this Object Snap behavior for extension lines, right-click and choose Options to open the Options dialog. Click the Drafting tab, and in the Object Snap Options group box, enable Ignore Dimension Extension Lines. Click Cancel to close the Options dialog. You can also create a center mark, which is a small cross that marks the center of a circle or arc, or a center line, a pair of broken lines that mark the center of an arc or circle. Center marks and center lines can be created automatically when adding a diameter or radius dimension. On the ribbon Home tab Annotation panel, you can find some commonly used tools for adding dimensions. You can find these same tools on the Annotate ribbon in the Dimensions panel, as well as many additional dimensioning tools.